Hey guys, welcome to another online math class. This video will be about feasible regions. And by the end of this lesson, we should understand that there are multiple solutions in inequalities, know what feasible regions are, and finally be able to graph a feasible region. Let's just pause the video here and take a couple of minutes to write these down. Alright, so before we get started on this, we're going to review simultaneous equations a little bit and how we solve them graphically. So if we had simultaneous equations like this, one at the top and one at the bottom, we would simply graph those two onto a Cartesian plane and find the point of intersection. So in this case, x is 4, as you can see there. So you'd write x equals 4 and y equals 3. So that's solving simultaneous equations. However, simultaneous linear equalities are similar but a little bit different. So you might have something like this on the top here. So that's the same as that, except we have different signs instead of the equals there. So in a set of inequalities, when we solve it, there isn't one single solution. There are actually multiple solutions. So the solutions are all of the points that lie in the region common to both the inequalities. So think about y is greater or equal to 3. In this case, any number bigger than 3 or equal to 3 will be a valid solution. So you might have maybe y equals 5, that would be correct. You might have y equals 7, that would also be correct. You might have y equals 8, you might even have y equals 999. So you can see how there are multiple solutions for an inequality. So we need to find the region that satisfies both these inequalities. So the one at the top and the one at the bottom. And this is known as the feasible region. And if we graph it on a graph like this, it is this area shaded in purple. Alright, so the formal definition of a feasible region is the region common to a set of inequalities. And this is all the points in the region that are a possible solution for the set of inequalities. Let's just pause the video here and make sure this is in our bound reference. Alright, otherwise let's move on to some example questions. So I'll do these with you step by step. So we're going to start off by graphing the feasible region for the following 4 simultaneous inequalities. So we've got a set of 4 inequalities here. So the first two is x is greater or equal to 0, and the second one's y is greater or equal to 0. So starting off with the Cartesian plane, that means my answer has to be in this section over here, because greater or equal to 0 means that x has to be positive x's are over here, and y is greater or equal to 0, that means the y's have to be positive or 0 as well, and which is that section there, which leaves me with that top right or the first quadrant of my Cartesian plane. So that's the first two done there. Let's move on to the next one. X plus y is smaller or equal to 8. So thinking about last lesson, the first step in finding this region is to graph the linear graph for this. So we're going to think about this as x plus y equals 8 for now. And we need to graph that line. And to do that, we need to find the x-intercept and the y-intercept. Remembering x-intercept is when y equals 0. So that gives me x plus 0 equals 8. So therefore x-intercept is 8. So just over here. And my y-intercept is when x equals 0, so that's going to be 0 plus y equals 8, which is y equals 8. So there we go there. And we're going to draw a line to connect those two. And there we go, that is our line. I've just fixed up that line a little bit. And now we need to find out which region we're after. Are we after this part here or that part there? So once again, going back to last lesson, to identify which section we're after, we're just going to substitute any value within this top right quadrant that's not on the line into that equation here. So that's the area that satisfies this part, this inequality, and that inequality. And my next step is to graph this line here. So 3x plus 5y is smaller or equal to 30. So in this case, once again, I need to find the x-intercept and y-intercept, remembering y-intercept is when x equals to 0 and x-intercept is when y equals to 0. So let's start off with the x-intercept. That gives me 3x plus 5 times 0 is smaller or equal to 30. I'll just change that to equals. That gives me 3x plus 0 equals to 30. So therefore x equals 10. That's my x-intercept. And my y-intercept is going to be 3 times 0 plus 5y equals 30. That gives me 5y equals 30. Y equals 6. So x-intercept equals 10. Y-intercept equals 6. So I'll just graph that in. That's x equals 10 is over here. I'll just redraw that. And y equals 6 is up there. So once again, just get a ruler, connect the two lines like so. And now I need to find out whether I'm after this region here or that region there. And in this case, it's most likely going to be on the bottom part, but we're just going to double check that. So once again, just pick any value that's not on the line that satisfies these three conditions. So ideally it should be in here somewhere. So I'm going to go with 0, 0 again, because that works for this case, because that's within these three areas. So let's just do that. 3 times 0 plus 5 times 0 should be smaller or equal to 30. That's the region we're after. And 0 is smaller and equal to 30, so that is correct. So the area that satisfies all of these conditions is going to be, I'm just going to shade it in blue, that part there. That is the feasible region for these 4 inequalities. And just finishing off our answer, we need to label the intersection point. So that point, if you graphed it correctly, that should be 5, 3. And this area here, just make sure you label it as feasible region. So you might want to write it in there if you can, or you can draw an arrow and just point out that that is the feasible region. So key points, make sure you got the intersection point of the two graphs and that you've labeled the feasible region. Alright, moving on to the next question. So once again, a very similar one. Graph the feasible region for the following 4 simultaneous inequalities. So I've got x is greater or equal to 0 and y is greater or equal to 0 again. So once again, that means my first region is going to be in this top right quadrant. So we're going to be working in that part. And the next one, x plus 2y is greater or equal to 10. So once again, just drawing that graph for the first one by finding the x-intercept and y-intercept. So in this case, my x-intercept is going to be x equals to 10, and my y-intercept is going to be 0 plus 2y equals 10, y equals 5. And let's just draw those 2 points in. X equals 10 is down here, it's my x-intercept, y-intercept will be up there. And if I get a ruler, connect those 2 lines, that's what I should get. Once you've done that, I need to determine whether I'm after this area or that area. So once again, just substitute a value. I'm just going to go with 0, 0 again. So I'm going to have 0 plus 2y is smaller or equal to 10. That should be 2 times 0. That gives me 0 is greater or equal to 10. I should have said that before. And in this case, that is not true. So the part we're after is going to be up here. Alright, next step is to graph this equation there, or inequality. So my x-intercept is going to be 6x plus 4 times 0 equals to 36. 6x equals to 36, therefore x equals 6. And for my y-intercept, 6 times 0 is going to be 0, so I'm just not going to write that in. Gives me 4y equals to 36, so y equals to 9. And plotting those 2 points, y-intercept is 9, x-intercept 6. Get a ruler, connect those 2 points, and that's what you should get. So the region for my first graph was this part here. I'll just shade it a bit more. All of that. That's the area we had at the start. And now I've got my second graph like so. And I can see that my feasible region will be this part, so I can't include this little section, which is part of my first answer. So my feasible region is just that top part there. Just shade it in. Make sure you label it as well. Feasible region, and also make sure you tell us what that intersection point is. In this case, it will be 4, 3. As you can see, go right 4 and up 3. So that's how we find the feasible region graphically, and that brings us to the end of this video. Thank you guys for watching, and I'll see you guys all back online.